Hello. In previous video, we have learned about line segment, ray and a line in terms of set of points. Now in this sixth video of basic concepts in geometry, we are going to learn more about segment, ray and line. What's that? Let's continue. The fourth point in that is congruent segments. All these things are very easy. So we are going to understand and learn quickly. So what is this? If length AB is equal to length CD, means there are two segments AB and CD, and if their lengths are equal, then we can say that two segments are congruent. So this should be the condition which should be fulfilled. Then we can say segment AB. What is this? This is symbol of congruent and segment CD. My dear students, many times students draw this symbol of congruence, which should be drawn in this way, is equal to side, and then you can say this is like a 2 something. Okay, this is slanting 2. But many times students draw something, so it is, instead of starting with down, they start with up, and this way they go, which is wrong. Please do not do such blunder mistake. Please do practice of this correct symbol of congruence in the initial stage. Once you understand how to write, it is not at all difficult for you. Okay. Now, let's learn what is the properties of congruence of segment. There are three properties. First is reflexivity. What is this reflexivity property? Segment AB is congruent to segment AB. This is written in symbol. What does it mean? In words, we can say every segment is congruent to itself. Okay. So, AB can be replaced by any other segment. Segment PQ is congruent with segment PQ, segment RS is congruent to segment RS, and so on. So this is the first property, reflexivity. Every segment is congruent with itself. Okay, what is the second? It is symmetry. What is the symmetry property? If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. In words, we can say if one segment is congruent with the other segment, then that other segment is congruent with the first. So if one segment is congruent with the second is also congruent with the first. Okay. And this is the third property related to congruence of segment, and it is transitivity. What is this transitivity property? If segment AB is congruent with segment CD and segment CD is congruent to segment EF. So here we can see that there are three segments, AB, CD and EF. So if first segment is congruent with the second and second is congruent with the third, then what? Then segment AB is congruent with the segment EF. Means if first segment is congruent with the second and second is congruent with the third. So here the second segment is common between these two pairs. Then the remaining two segments, means segment AB and here the remaining is segment EF, they are congruent to each other. In other words, suppose if it is segment AB is congruent to CD, and again if we have here we say segment AB is congruent to EF. Now here if AB is common, we can say CD is congruent to the EF. Okay. So this is third property, transitivity. So the first property is only one segment itself. Here the second property about two segments, and here this third property about three segments. How to remember these names of these properties is very easy. If you little bit observe, you can see that the starting letters is R, S, and here it is T. So they are exactly in the alphabetical order. O, P, Q, R. This is the alphabetical order. R, S, T. R is the first, reflexivity. S, symmetry, and T, transitivity. This is just a tip to remember you the names. Once you understand R, you have to recall reflexivity. Once you say S, it is symmetry. And when it is T, it is transitivity. Okay. So these are the properties of congruence of segments. Then what is the midpoint of a segment? If A dash M dash B, it means point M is between points A and B. Betweenness. This is betweenness concept. We have learned it before. These are the three distinct points, collinear points. And this is the situation of betweenness. And segment AM is congruent to segment AB. Means this segment, distance between A and M and B it is exactly same. These lengths are equal. Segments are congruent. In that case, M is called midpoint of the segment AB. And my dear student, every segment has one and only one midpoint. What is the meaning of this terminology, one and only one? It means every segment has one midpoint. Okay, that's sure. For sure it has one midpoint and not more than one. It means only one. So, sure short, exactly one midpoint. Every segment has exactly one midpoint. It is written in mathematical language like this, one and only one. Okay. Now come for the comparison of the segments. If we are comparing two segments and if we find that they both are equal, then we can say that is the midpoint. But it might, or they can say congruent also actually. Okay, so if these two segments are equal, their lengths are equal, they are congruent. But if they are not equal, then what? Then there is a possibility that one segment is smaller than the other. So if length of say segment AB is smaller than length of CD, then we can say segment AB is also smaller than segment CD. Very easy to understand. Whichever length is smaller, that segment is smaller than the other segment. Now, what is the perpendicularity of segments of ray? It's actually if the lines containing segment or rays are the symbol we use for perpendicular. Ulta T, upside T is what? Perpendicular. Means they intersect each other at right angle. Then that rays or segments are also perpendicular to each other. For example, if I have drawn here two segments AB and this is PQ. If I ask you, are they perpendicular to each other? You will say they are not intersecting, so there is no question of intersecting at right angle. So how can be they perpendicular? But no, our definition is what? If the lines containing the segment and ray are perpendicular. Means if we extend this line. Now here I don't think we should extend this line AB. If I extend this PQ line, okay. And this PQ line is meeting this segment AB here at point at right angle. If this is right angle, symbol of right angle, then these two segments, or we say ray, they are perpendicular to each other. Okay. And the last point of this, what we have to learn is distance of a point from a line. So this is line AB given to us, and this is somewhere point outside where we have point C. Now what is the distance of point C from this line? Okay, how to find? Now this point C can be joined with many points on this line. Okay, we can continue like this. So exactly which distance we should take it as distance of point C from line AB. My dear students, if I ask you if you want to go from one point to another somewhere, you have to go. How you will go? And if you have 4-5 routes to go, I am sure that you will prefer the shortest way, correct? In that way also, out of all these segments, we will choose which is the shortest one in this all segments. And if you observe, if the segment which is perpendicular to the given line is going to be the shortest of all these segments, hence the perpendicular distance, perpendicular drawn from the point to the line, it is the shortest distance. That's why this perpendicular distance is called the distance of a point from a line. If I name it as say D over, and if CD is perpendicular to AB, length CD is going to be your distance of point C from line AB. Of course, that D point is lying on the line AB. So, we have learned the small concepts which we are going to use in this lesson, and in geometry itself many times we have cleared about all these concepts in this video number 6. Next video we will learn how to solve sums from practice set 1.2. Thank you. If you like this video, please like, share and don't forget to subscribe the channel. Thank you.